Section 1.4 is a lesson that's going to involve some of our reciprocal identities and our reciprocal functions. We're going to go a little more in depth. So, first let's warm up a little bit. Remember, we have a right triangle, and they want us to fill out some information about the different trig functions. First, let's talk about sine. Remember, sine was, you either used the formula opposite over hypotenuse, or when we were in the coordinate plane, we used the formula y over r. The cosine of an angle, remember, was adjacent over hypotenuse, and in the coordinate plane, we used the formula x over r. And the tangent was opposite over adjacent, which would be the formula y over x in the coordinate plane. Now, this example here is not in the coordinate plane, so we're going to use our old definitions for sine, cosine, and tangent. The sine of a, let's see, opposite over adjacent would be a over c. The cosine of a would be adjacent over I said the wrong thing. Sine was opposite over hypotenuse. So cosine of a would be adjacent over hypotenuse, so b over c. Now this time we're going to switch to b. Tangent of b would be opposite over adjacent for b, which would be b over a. And then sine, I'm guessing they meant b here. Sine of b would be opposite over hypotenuse, which would be b over c. And again, notice that when you switched angles, the cosine and sine of the switched angles were going to be the same value. And now we're going to be in the coordinate plane, so we're going to go back to our definitions for coordinate plane. So sine was y over r, cosine was x over r, and tangent was y over x. So cosecant would be our reciprocal, which would be of sine, r over y. Secant is our reciprocal of cosine, so r over x. And cotangent would be the reciprocal of tangent, so x over y. And let's see here. That's all they wanted there. So x and y, how would you find r? Remember, oops, that's not very good. Since this is, that is a y. Since this is a right triangle, if you think back to your geometry days, you could have found the value of r by doing Pythagorean theorem. And we also know that Pythagorean theorem is distance formula, so it would have been the square root of just simply x squared plus y squared. The reason we don't have any other points for distance formula is because it's originating at 0, 0, so subtracting a value from 0 just gives you that same value again. Alright, let's fill out this chart. This is introducing you guys to the unit circle. And I want you to think about where your ordered pairs are if we use a radius equal to 1 on all of these. So if I go over to this point here, just think of it like a coordinate plane. If you're over 1 unit and up nothing, that's the point 1, 0. Up here, which is 90 degrees, if you're over nothing but up 1, it's the point 0, 1. Over here, if you go over 1 unit, that's the point negative 1, 0. And then down here at 270 degrees, this is over nothing but down 1. So those are the axes or the quadrantial angles filled in for us. Remember, the radius is always a 1. So let's fill out this chart, and we can do it kind of fast if you think about your formulas for sine, cosine, and tangent using your x, y, and r. And we're going to do the other quadrantial angles too, 180 and 270. So let's start with 0. The sine of 0, remember, is y over r, so 0 over 1 is 0. The cosine of that same angle, or in this case a point, would be x over r, so 1 over 1, which is 1. The tangent would be y over x, 0 over 1 is 0. Now cosecant is the reciprocal of our sine, and remember, originally we set up sine, I probably should have done it like this. Cosecant, original sine was 0 over 1, so cosecant would be 1 over 0, which is undefined. Secant, if I flip a 1 over 1, I still get a 1. And then cotangent, if I flip a 0 over 1, I get a 1 over 0, which is undefined. Okay, at 90 degrees, this time sine would be y over r, which is a 1. Cosine is x over r, which is a 0. Tangent would be y over x, which is undefined. Cosecant, if I flip a 1 over 1, I get a 1. Secant, if I flip a 0 over 1, I get an undefined value. And cotangent, if I flip a 0 over 1, I get 0. And you should notice kind of some patterning here, kind of a zigzag of where the undefines are located. Okay, for 180, this time y over r gives me a -1. Cosine would be x over r, which is 0 over 1, which is a 0. Tangent would be, let's see, where am I at? Y, oh, that was the wrong thing. Let's back up. I did not do the right thing. Okay, back to sine. Y over r would be 0 over 1, which is 0. Thank you. I noticed I screwed up because I didn't notice that zigzag anymore, and that's why I backed up. Okay, cosine would be -1 over 1, x over r, which is a -1. Okay, now tangent would be y over x, which is 0. Cosecant, if I flipped 0 over 1, I'd get something with 0 in the denominator, so it's undefined. Secant flipped would be -1. So cosine flipped was secant, -1. And then cotangent is tangent flipped, which again is going to have 0 down in the denominator, so it's undefined. And again, I see this kind of zigzagging pattern. That should continue. Okay, for 270, sine is y over r. So let's see, we've got, where are we at? -1 over 1, which is -1. Cosine would be x over r. 0 over 1 is 0. Tangent is y over x. So -1 over 0, which we know is undefined. Cosecant, if I go back and flip my sine, I get a -1 still. If I flip my cosine, I'm going to get an undefined value. And if I flip my tangent, I'm going to get a 0. And again, you notice the zigzagging pattern, and that should happen. One other thing I want to point out to you is on the unit circle, when we come up with ordered pairs on the unit circle, and the unit circle is only when you have a radius of 1, you're going to notice that the ordered pairs, the x value is always their cosine, and the y value is always their sine. So if I look down here, for instance, at 180 degrees, the sine came out to 0, and look at that. The y value is a 0, and the cosine is supposed to be a -1. Did it come out that way? Sure did. So we're going to notice that pattern as we get deeper and deeper into the unit circle. Now this is the worksheet 1.4. This is technically a homework assignment for you, but I'm going to go through a few of them with you. So when I look at sine, the reciprocal of sine would be cosecant, so I could write that as 1 over cosecant, because reciprocal means to flip around the fraction. And then same thing with, let's jump ahead to tangent. If I have the reciprocal of a tangent, 1 over tangent, excuse me, you could either write it as tangent, or you can write it as cotangent, his reciprocal. Secant's reciprocal, remember, was cosine, and I think you can continue this on your own. Alright, so using only sines and cosines, I want you to kind of rewrite these. This is kind of an introduction to what we're going to do in the next lesson. Oops, quit that. So tangent, if you remember from your geometry days, is really a sine value divided by a cosine value. Therefore, cotangent would be the reciprocal of that, cosine over sine. Secant is the reciprocal of cosine, so we can rewrite it as 1 over cosine. And then who's back here? Cosecant is the reciprocal of sine, so we can write it as 1 over sine. Alright, finding distance. I think you guys can handle that all by yourself. Graphing. Remember, this guy's going to come out to be a circle, and this guy will be a parabola. So the first thing I would do is identify my vertex. You can fill out this chart just fine. Oh, by the way, my little hint to you is go back to your notes and review what that meant. We already filled out this chart, but you can do it again. And then they want you to do Pythagorean theorem on these. I'm sure you'll do fine. And then these problems are just a little reminder of how to do 30, 60, 90s and 45, 45, 90s once you get to, let's see, this one and this one. So refer back to your notes on that. Complement and supplement and coterminal, all old ideas. And then this is a problem where I would start by drawing where my terminal side is located, so negative square root of 5 and 2 would, I don't really know exactly what it looks like, but something like this. And then your job is to find R, and then you can fill out your 6 trigonometric functions. Same thing with the next example, and same thing with the last example. So you're all set. You have a book assignment on 1-4 and this worksheet to do. Good luck.